Hello, good day, everybody. We'll give it a few more minutes while people are dialing into the webinar. Just a brief moment longer and we'll get started. Thank you to those who are on. Okay, it looks like we have a quorum of people, so let's go ahead and get started. Welcome, everybody. This is the Railway Modernization Sustainable Freight Rail Solutions webinar with Downer and ZTR. We're appreciative of you joining us today. We hope that everybody's found safe and are in a good location. Normally, I think we're used to doing safety briefings. We might skip that for our webinar today, but please be aware of any unsafe conditions around you and make provisions to be safe. Wanted to take a quick minute to introduce the panel of individuals that will be meeting today. We have Ashley Thompson. He's told us to call him Ash with Downer. Ash has 16 years in business development and sales in the rail and transport industry. He's a seasoned leader. He's held multiple senior positions at Downer across Victoria and Queensland, focusing on business growth, bid management, contract negotiations. We're great to have him on the panel. Also from ZTR, we have Amarjit Sura. We call him Am. Some people call him other things, but we lovingly refer to him as Am. Am's been at ZTR for just over 25 years, I think he was telling me. So Am's been here a while. He's held a number of roles. Today, currently, he is the Director of Product Management at ZTR. Also, we'll have Lucas Poole. Lucas is our Director of Technology at ZTR. He has 15 years with the company. He has a very deep engineering background. He's held multiple roles at ZTR over his 15 years. We're grateful to have him too. I'll be your host, at least for the beginning of this webinar. My name is Garrett Riley. I'm the sales guy that just talks. That doesn't know anything, but I'm grateful to be here. I'm grateful for the opportunity. I hope you enjoy your time with us. I hope you enjoy the things that you're able to gather from our conversation. Just a quick, brief introduction of ZTR, who we are. We've been doing locomotive modernizations, digitalization, and the remote monitoring since the late 80s. We've been in business over 36 years. Our headquarters are in London, Ontario, Canada. So a little hop, skip, and a jump away from where most of you are at today. But we have lots of experience designing control systems for rail applications. We have great engineering resources at our company who can do really great things and are very well experienced and professional in doing that. And we have assets and resources all over the globe. And we've been around and we're trying to understand the markets and specifically your market where you're located. So we appreciate you again joining us today. So with that, we'll turn some time over to Ash.
Yeah, cheers. Thanks, Garrett. And also, I just quickly want to thank the ZTR panel for making themselves available across Australia and New Zealand time zones, which normally aren't so favourable for you guys, so I appreciate it. Before I touch on Downer Rail and Transit Systems RTS, I'll just give a quick brief overview of Downer Group as a whole. We are a leading provider of services across Australia and New Zealand, with our purpose is to enable communities to thrive. We have a key focus on national security and decarbonisation, including areas such as roads, rail, airports, power, gas, water, telecommunications, health, defence, many other sectors. We're fully involved across a whole gamut of areas. Last financial year, we turned over around 12 billion, and we have a workforce of more than 30,000 people, which makes us one of the largest private employers across Australia and New Zealand. For RTS, we have a really proud rail history, which is over 150 years. We're across 15 sites, and in rolling stock, we've manufactured and overhauled over 3,000 locomotives and passenger cars. Recent flagship projects for us is HCMT down in Victoria, QTMP here in Brisbane, where we're designing, develop, and providing new trains for the upcoming Olympics and for our new freight business. We've recently signed with Fortescue Zero to develop the first electric battery, most efficient locomotive, and our goal is to be production ready for that loco by 2027. Now going on to the partnership. So we re-entered the freight market just over 2 years ago after the embargo finished with Progress Rail. With that, we've had a clear focus on decarbonisation. ZTR is a perfect partner for us to help our customers see immediate emission reductions. Downer being the local presence and agent for ZTR, we're able to offer a number of engineering supports, undertake design, modifications and installation of all the ZTR product range. We're able to do this at either our site or one of your sites. Our support can be as large or big as you require. At the end, I'm going to touch on Ausrail because ZTR will be accompanying us there, so I'm very pleased to do that, so please come and say hi. But now I'll pass over to Garrett to go into the ZTR product range. Thank you.
Thanks, Ash. Well, we'll start talking about the products. I like I said, I'm just a pretty face, so let's turn over to somebody that's a lot smarter, and we'll let him introduce this for us.
Thanks, Garrett. I don't know about smarter, but appreciate that. Yeah, good morning, good afternoon, good evening, everyone, wherever you are. Happy you could join us. And yeah, Ash, as you noted, it is getting on a little bit late on our side of the world here, but hey, in Southern Ontario, Canada, it's this time of year, the days are getting dark, it's getting cold. So usually by this time, some of us are curled up in bed wanting to go to sleep. So this is actually a nice reason for us to stay out and about and a little more active. So grateful that you could join us here. So yeah, a little bit before we dive into the details of the products, a little bit about the history of ZTR with the products. So ZTR started in 1987, and in the early days, the focus was really on the control system in terms of the adhesion improvements, the world's first automatic engine stop-start system in the rail industry, SmartStart, which Lucas is going to dive into shortly here. And over time, the products have evolved with a lot of focus on performance improvements, and then diagnostics and remote monitoring. So it's great to have performance efficiency gains, but quantifying the results and synthesizing data into actionable maintenance items or being able to report out to stakeholders is very important. So advancements over the years with the control systems, but connectivity has been a real strong focus as well. And leading us up to today, we're building upon all those solutions. We've got a larger focus now on energy management systems like supercapacitor solutions, which we'll talk about, battery management systems. And some of you may be aware we're developing a battery diesel hybrid mother-daughter set with Union Pacific here in North America. So quite the journey, a lot of exciting things, and we're going to dive into, I think, about 3 of our products here today. So with that, I think I will turn it over to Lucas.
Thanks, Sam. So the first product we're going to dive into today is one of the original products that ZTR ever developed. But even though it's been around for a long time, it's still very viable in the market today, and that is our SmartStart. It's an automatic engine start-stop system, and in a few slides, I'll go through kind of how it works, what the implications are, and why it's beneficial. So SmartStart rose from some industry challenges. One of the first and most major challenges being manual engine management. No matter how good your operating procedures can be, relying on humans to do things can result in difficulty getting the maximum benefit out of shutdown time that you can. In a lot of cases, we'd see where locomotives just wouldn't be shut down. They'd just be left running all the time because it's easier, and on a manual scale, it's difficult to monitor all the different parameters and items that you need to understand when it's safe to shut down a locomotive and when to restart it so that you're able to utilize it immediately. Another challenge is a complex ecosystem and diverse fleet. Across a lot of the railroads, there are many different locomotives from different OEMs that require different standard operating procedures, and trying to have a well-informed operators that know when to shut down each unit, when each unit might have different parameters that need to be followed, can make that manual intervention even more complex and difficult to get the most benefit out of. Uncertain quantification of benefits. What we find is some railroads just don't even have the information of how their units are being used today, how much their units are idling, and even what the potential is for the ability to reduce fuel consumption, reduce emissions, and ultimately save money. Another one, resistance to change. Finding that in a lot of cases, without a lot of good solid facts and data to back something up, it can be very difficult to convince someone that it's worthwhile to implement a new technology or change standard operating procedures in order to redeem some of the benefits of that change. And inefficient emission reduction. This goes back to, again, the manual intervention. It's very difficult to get the maximum shutdown time out of a locomotive when it's being manually monitored and operated. So thus AESS technology was born. What is AESS? It stands for Automatic Engine Stop-Start System, and it operates by intelligently managing the engine's shutdown and startup procedures automatically. So it's not done on a manual system. This is done through sensors that monitor crucial parameters and operational status so that it understands when is a good time to shut down and restart the locomotive to ensure that you're saving fuel when you can, and that it is in a position to be operated immediately when it needs to be. The AESS system makes real-time decisions based on that predefined criteria to understand when to shut down or restart, and it enhances the operational efficiency and while minimizing the human intervention and error because it is automatically operated. And this is where SmartStart came in. It is the most trusted AESS system in the industry with over 30+ years of global history. It was the first AESS system on the market, and at this point we have over 10,000 SmartStarts installed globally. So how does it work? Getting into a little bit more of the details, there's a number of parameters that SmartStart monitors, some of them operational, some of them more environmental. So brake pipe pressure being an example of one, where we make sure that the unit is in a parked idle state before we shut down so that it's not in the middle of being used. Ambient temperature is another one. The SmartStart will monitor that in cases where it's too cold out. We'll keep the engine running so that you don't run the risk of your coolant freezing. Engine temperature. This is to ensure that the engine is in an operating temperature where it's in the ideal operating range, so that when you do restart, you can immediately start utilizing the unit without having to wait for a warm-up cycle or anything like that. And then ensures that the engine gets up to a good temperature before it shuts down, so that there is time during that shutdown where it can remain shut down and still in the operating range. Battery health. This is another one where we monitor the state of the battery charging to ensure that we're not prematurely shutting down when the battery is not charged sufficiently, so that there is sufficient battery charge to restart the locomotive at a later date when needed. SmartStart health status is another item that we monitor. This is looking at the status of the health system itself, the health of the locomotive, and ensures that if there are any issues where it might not be able to restart, it's not shutting down the locomotive so that it remains running. And the operator console is the last one, where we monitor a number of inputs from the operator to ensure that the unit is not actively being used and that it's in a parked idle situation, so that we're not shutting down and then immediately starting back up because the operator is trying to use the unit. Here's an example of a few of the parameters that we look at. This is not an exhausted list. There are some others that can be options, like main reservoir pressure, things like that. But as you can see, ambient temperature, typically we're looking for it to be above freezing to make sure that we don't run into issues with the water freezing in the block. The engine water temperature, again, this will be dependent somewhat on the engine and its specs that you have, but generally speaking, somewhere around that 100 to 120 degrees Fahrenheit is that area where we want to keep it above that to ensure that the engine is ready to be loaded on a very short basis, so that we're not impeding any sort of operations. Battery charging current is to make sure that we're not shutting down the unit until the battery has been sufficiently recharged after a restart. And the battery voltage we use to make sure that we're not letting the battery get too discharged when it is shut down based on hotel loads, so that it restarts and recharges the battery while there's still sufficient energy to do so. Runtime after loading is a configurable setting. There is a maximum to it generally, but somewhere between 15 and 30 minutes. This is to ensure that when you are loading the unit, that there is some give time while it remains idling, so that if you're in the middle of some moves or things like that and you're just parked for a couple minutes, that the unit's not shutting down on you when you're in the middle of using it. Brake cylinder pressures, just to make sure that that you're actually parked the unit and you have the brakes applied. And then reverser position is one of those ones for looking at the operator. One of the things that can be done with the reverser position actually is if you're running in a consist and you have the whole consist shut down, you can use the reverser to restart the whole consist in preparation for making a move. So if you know that you're going to have a green light in a moment or going to be making a move in a few moments, you can throw the reverser, get the whole consist started up and ready to go, and then get moving immediately as soon as you can. So some of the features, again, fully automated operation, eliminating the need for any sort of operator intervention or operator monitoring. The SmartStart will monitor all the parameters necessary and make sure that we're maximizing the amount of time that we can be shut down, thereby reducing fuel consumption and reducing emissions as well. So this optimal emission reduction leverages back to that fully automated operation and monitoring the parameters that we do. And universal applicability, when we install the system, it is more or less transparent across different manufacturers, different models, different ages of locomotive. And what makes that nice is that operator usability is more or less consistent across them. Different operators don't need to understand the system differently when it's on different units. It will operate automatically once it's installed and allow you to save as much fuel as possible without needing to have complex differing operating procedures across your different models of locomotive. Some of the benefits: accurate and up-to-date data. We have a pretty comprehensive reporting structure that comes with the SmartStart. That's both for compliance and for being able to monitor the operation of the unit. So some of those things include things like detail reports, where you can see what parameters are preventing you from shutting down, what parameters have caused the most restarts, And you can utilize that data to understand if there are areas where you can further improve your fuel savings and emissions reductions. It is flexible, expandable technology, allowing for expansion in the future if there are additional sensors and additional interfaces. Generally, we've designed the product to be able to be expanded to support additional items in the marketplace as they come up. And there's some options such as load shedding to help extend shutdown time by shedding light loads and things like that. Battery saver is one where if you have a manual shutdown, it helps prevent excessive load drain on the battery so that when you do get back to the locomotive, you have a better chance of not having a dead battery. Along with our SmartStart, we have a great pairing with it that is referred to as Saver, and it's our remote monitoring. So this remote monitoring platform allows remote access to the data through our platform. Things like GPS location geofencing, so that you know where the locomotive is. You can get alerts when it's going into different areas that you don't necessarily expect it to. Fleet reports. This is a very powerful tool where you can look at the fleet as a whole and see if there's problem units. You can go into individual unit reports once you understand there are problem units and see what problems there are. For example, say you see a unit that has excessive main reservoir idle time. That might be an indication that you need to go look at that unit and tighten up the air system. And by tightening up the air system, you may be able to reap additional fuel saving and emissions reductions. Automated alarm notification. So this allows real-time alerts for certain locomotive events. Things like if you have a manual shutdown or a engine protection device initiated shutdown, like a non-automatic shutdown, and the temperatures are close to freezing or below freezing, you can get an automated email alert letting you know that your locomotive is in a position where you might have water get dumped or something else where you need to get to the unit and take some action to prevent some potential damage. And then operational insights, again, along with the fleet reports, seeing what the units are starting and stopping because of. You can also see some utilization data and understand just how the units are being used, and perhaps use that data to more efficiently utilize the assets that you have. So with all those things together and the data that we've had in the past and the use cases we've seen, typically we see on average about 20,000 to 30,000 liters of fuel savings per year per unit. And that generally results in a break-even point on this product of less than a year. And with that, I'll pass it back to Em.
Thanks, Lucas. Appreciate the rundown on SmartStart and the remote monitoring, especially in the value of it, which I'll come back to a little bit later on when we talk about some of our other products. Before I continue, I think now would be a good time to mention that if you do have questions, you can put them into the chat bar. And towards the end of this segment here, we will answer your questions as best we can. So please, if you have questions throughout the discussion here, feel free to drop some questions into the sidebar and we'll come back to them. So the next product we'll talk about is KickStart, supercapacitor-based technology and locomotive starting assist. So how did KickStart come about? So let's talk about batteries and in the context of locomotive engine starting. So decades ago, starting lead acid batteries, which is a great technology and a great product, it works really well in the application it's intended for. It's as long as it's maintained, it's highly recyclable. So it's a great product when it's used right. And decades ago, that was certainly the case on locomotives. So the charging, they were always charged optimally. The engines ran a long time. The stop-start was very infrequent. This was before automatic stop-start technologies and people doing manual shutdown to save fuel. So, and there was no hotel loads. Lucas referred to hotel loads earlier. So what we're talking about is loads when the engine is shut down, drawing power off the battery. Not a lot of them when locomotives were, maybe 1970s, 1980s. Next slide, please. Now you have legislations over the decades and the increased drive for efficiencies and reducing operating expenditures. So now batteries are no longer meeting the performance requirements of locomotives, a lot of batteries anyway. Charging is inadequate because the engines run less than they used to. The stop-start frequency is much higher, which is taxing on the batteries. And the hotel loads, so here we're talking about modern safety systems, radio systems, comms, monitoring systems that often have to stay powered when the engine is shut down. They're using the lead acid batteries to power them, and this is not what really starting lead acid batteries were meant for. So you combine all these factors, it leads to the batteries being in a constant state of deficit charge, leading to damage and sulfation on the plates. And what that means, long story short, reduced capacity and performance of the battery, which could lead to engine starting failures, among other things. So this is where a solution like KickStart comes in, which is based on a supercapacitor. It's a great way to address the issues at a reasonable cost and effort. So I'll just talk briefly about some of the advantages of supercapacitors over batteries. They have a much higher power density than batteries. Batteries still hold the edge when it comes to energy density, but when it comes to power density, the ability to quickly discharge that energy to turn the engine and provide the torque that's required. This is where supercapacitors excel, and they can recharge much faster than batteries as well to be ready for the next starting event. Supercapacitors also have pretty strong performance across the wide temperature ranges, and unlike some battery technologies, their performance is not negatively impacted at colder temperatures, resulting in reliable operation across the environmental range. So how does a product like KickStart work? So on the right there is a simplified diagram of some key locomotive components involved in locomotive starting. So you have the auxiliary generator, which is providing power when the engine is running. You have the locomotive starting batteries. A very simplified diagram of the KickStart capacitor module, the capacitor inside. So the way it works, and then you have your starting circuit. It could be starting motors, it could be generator start, it could be traction alternator start. KickStart is pretty agnostic to the type of electric starting mechanism you have. So in step one, the locomotive engine is running and the supercapacitor charges off the auxiliary generator, just like the batteries are being charged from the AG as well. When the engine is off, the supercapacitor is isolated from the battery system and maintains its charge. It holds that charge, and then during the next engine crank cycle, the supercapacitor comes online and helps the batteries to provide that peak current or the torque to successfully start the engine. So in cases where the battery can't provide that quick power delivery, KickStart offloads a battery and provides that peak torque and turns the engine successfully and gets it to the successful rotating velocity to crank the engine, 60 RPM, 70 RPM, whatever it may be. The engine runs, and then the cycle continues to repeat itself. So that's KickStart's operation in a very simplified format. So in doing so, it dramatically improves the locomotive starting reliability, which means it's improving the locomotive availability. And availability, it's a term often used here in North America, maybe in other regions as well. It's simply the ratio of the time the locomotive is available for revenue service against the total time for that reporting period. So it improves the availability. So we'll take a close look here at the impact on the voltage characteristics of the battery when KickStart is involved. So on the left with the red line, that's the battery voltage right before an engine start, let's say just above 60 volts, the nominal voltage. When the engine starts, the drag on the battery and the current, the voltage drop results in a huge drop in the battery voltage, sometimes as low down to 30, 40 volts, maybe lower. This can result in a couple of things. It reduces the rotational velocity of the engine if it does get turning. The other thing is when the voltage drops to that level, it could cause the onboard control circuits and relays and contactors to reboot, and which means a failed engine crank. And on the right, the diagram with the blue line, so you have the battery voltage again at 60 volts, but in this case, the voltage drop is minimal because KickStart is providing that peak torque and power at the engine starting sequence at the beginning. This reduced voltage means no computer dropouts and no control circuit dropouts. And it also means a higher engine rotational velocity, which means the engine is going to start faster as well. So just a bit of a discussion there on the voltage characteristics and how KickStart helps and how it impacts in a positive way the engine's starting reliability. So having gone through a little bit of the technology and how it works, we'll move on to discussing the benefits, talking about improved locomotive availability because the engine starts more successfully, the reduction in fuel consumption, and we have studies that show the technology can improve AESS performance, leading to additional fuel savings on top of what the AESS baseline performance is and reduced emissions. So I'll just pause briefly there. So Lucas mentioned earlier systems like SmartStart. They'll shut down when certain parameters are satisfied, like battery charge. They'll restart if certain parameters are not satisfied, like battery charge. Our studies have shown that over time, the positive impact of KickStart on the battery means less engine idling time, waiting for the batteries to charge, so meaning the engine shuts down sooner, and less AESS battery initiated restart, meaning the engine is shut down longer, enhancing the fuel savings with AESS. And then extended battery life. So a lot of locomotive batteries, in studies we've seen, sometimes they'll last as low as 1 to 2 years, and they're changed out or discarded or recycled. KickStart can help extend the life of those batteries and mask the deficiencies with engine starting, reducing the frequency with which battery life needs to reducing the frequency of which batteries need to be changed. So we'll talk a little bit about the tangible savings and the impact KickStart has, the return on investment, which is obviously important if you're making a decision on investing in this type of technology. So we have numerous case studies of locomotives before and after KickStart's been installed, similar class of locomotives, similar operating environments. And here's some of the numbers that we've seen with the implementation of this technology. So the impact on fuel, and this is per locomotive in US dollars, is about just over $4,000 a year with the fuel savings. If you think about the operational impact, maybe the penalties incurred because of a failed train because the engine didn't start, maintenance costs, crews having to be changed out, we've seen savings of about $6,000 a year in that regard. And then extending battery life, as I mentioned, reducing the frequency with which batteries have to be changed, about $3,000. So this adds up to about $13,000 to $14,000 a year with KickStart per locomotive. Next slide. And then projected over a longer period of time, let's say 10 years, 5 to 10 years in this. I went through all the background of the data on the previous slide, so I won't cover that here. But if you look at over a 10-year period, KickStart is expected to generate more than $112,000 in savings. And given that the KickStart life is going to be well beyond the 10 years and the low investment costs, the payback period being 1 year, the tangible numbers here should be compelling. Okay, I'll just, if you'll excuse me, pause and take a sip of water. Okay, next we'll talk about the NEXSYS locomotive control system. So traditional locomotive control systems, they come with their challenges with respect to today's requirements. The technology can be outdated, can be obsolete, parts can be hard to find, performance inadequate, and the maintenance and reliability. So lack of information to properly diagnose the locomotive, components prone to failure, a lot of moving parts, lack of integration and compatibility. So today's locomotives have a plethora of cab electronics and subsystems that need to talk to each other for safety reasons and operational reasons. And the traditional systems don't have the capability to offer this level of integration. The inefficiencies in fuel consumption and performance. So here we're talking about the increased drive to increase, do more with less. So more pulling power, more efficiencies, more gains, reduce the fuel consumption, reduce emissions. And that leads into regulatory compliance. There's regulations in place for safety, for emission reduction, and others. And a lot of the traditional systems can't help comply. Limited data and analytics. So it's great to have an operating locomotive, but unless you have the ability to have that data synthesized into the actionable maintenance items that Lucas referred to earlier, the challenges can be enormous. Remote connectivity, the ability today to be able to dial into locomotives or see things remotely without having to send people on a 6-hour journey or catching flights. That's a challenge if you don't have that in place. And then the lack of predictive maintenance, not understanding when components may need to be replaced or maintained before a catastrophic failure may occur. So if you mirror that into today's modern locomotive requirements, that really means we're talking about needing seamless integration and interoperability between all these cab electronics and electrical subsystems we just talked about, enhancing performances and efficiencies, and having that superior reliability and less maintenance. So locomotives are out working more in revenue service, less time in the shop, not in revenue service. And improve safety and compliance, supporting those initiatives. And then real-time data analytics and insights, which I referred to. If you don't have these things, it can be a challenge. You want to know what's going on with the locomotive, and that ties into remote monitoring as well. If there's an issue before it even comes to the shop. So having that information ahead of time saves valuable shop time and labor as well. Scalability and flexibility. So knowing that you invest in something, locomotive control systems are not like our cell phones where the technology changes every 1 to 2 to 3 years. The investment is expected to last 10 to 20 years. So knowing that you can scale up, expand on your solution is important. And I talked about remote monitoring and data, and then having the ability to demonstrate to your stakeholders that the investment is providing the returns that you're seeing and having the tangible reporting in place. So these are a lot of the requirements of modernized locomotives today, and they should be solved with your control system. Next slide, please. And this is where a solution like NEXSYS comes in. And NEXSYS, we'll talk about NEXSYS 3i here specifically today, as the 3 would imply. It's in the 3rd generation of its product lifeline. The 1st generation is actually installed in New Zealand on DQ and DA class type locomotives, and then we went to NEXSYS 2 with a more focus on Dash 2 locomotives, and NEXSYS 3i evolved to build on that with a greater focus on more efficiency gains, propulsion performance, and remote monitoring and diagnostics as well. So NEXSYS, I'll just quickly walk through some of the features and benefits, the propulsion efficiencies, improving locomotive reliability and availability, reducing emissions and fuel cost reductions and meeting sustainability goals. Onboard diagnostics, being able to climb aboard and diagnose and see what's happening on locomotive, having an integrated driver's display, which I'll talk about. The remote monitoring is provided with it, and then demonstrating that excellent return on investment that comes as well. So the next couple of slides will touch on the propulsion efficiency gains that I referred to on the previous slide. So what we're talking about here is this was a test that was conducted at TTCI. So this wasn't ZTR conducting a test with our own instrumentation. This was conducted by an independent body and validated by them, and the data was provided and accumulated by them as well. So what we did here was we had 2 SD40-2 locomotives, and one of them was fitted with the NEXSYS 3i system, and the other was the original OEM-2 system. So we did pulling tests and adhesion tests on the same track portion, the same days, the same type of weather conditions, so pretty much as close to similar conditions as you can. And the first test was done on dry rail. And if you look at the graph, and I hope you can see it, if not, we're going to provide this presentation after, and you can zoom in to your liking. The blue line there, so there's speed on the bottom, tractive effort on the left Y scale. The blue line is a theoretical maximum, which is largely dictated by your traction motor limits, traction alternator limits. The red line is the Dash 2 system, and the green line is with NEXSYS 3i. And you can see with NEXSYS 3i on dry rail without sand, it almost matched the theoretical maximum tractive effort. And what this meant was at 2 miles per hour, so this was a lifting test, where wheel slips can really happen, there was a 44% increase at the tractive effort over the Dash 2 on dry rail. Next slide, please. So same locomotives, same control systems, same track segments, except in this case, Water was applied to the lead axles when we're doing these pulling tests. And again, the focus was on lifting tests and lifting tractive effort. So again, sand was not applied. The sanding mechanisms on the locomotives were disabled. And again, blue line is theoretical maximum on dry rail. Red is with the -2 and green was NEXSYS 3i. So a bit of a drop off on both, but even in this case with NEXSYS 3i, there was still close to a 30% increase in tractive effort. So this is a worst case, wet rail and no sand as well. So just to illustrate real quick on those two slides there, the type of adhesion gains you can expect to see over this type of OEM system. So when it comes to onboard diagnostics, there's plenty of HMIs and onboard displays out there. But some of the challenges that you see in the industry is they're not intuitive to use. They're you know, characters, there's lines, there's texts, there's codes that need to be looked up independently and not intuitive. So the graphical HMI that is provided with our NEXSYS 3i system, as I said there, it's graphical. It's used in plain languages. There aren't any codes to decipher. And it provides insights on the main locomotive parameters. So it could be if you're empowering, load test, dynamic brake, what the traction system metrics are. Also the system health status of the control system. And then the ability to drive outputs and monitor inputs on locomotive, every basically component NEXSYS is connected to. Some local authorities mandate pre-departure tests for your train, testing the fans, testing wheel slip light, testing the air system. That's built into the NEXSYS 3i system as well. Automated testing for contactors, automated load tests, so running through the notches automatically, and then recording the horsepower and other parameters that are important to know during load test. Diagnostic information, so there's graphical flow diagrams, and again, it might be hard to see on the bottom right, but there's a bit of a tree diagram for troubleshooting. And then reports. Some of the reports Lucas mentioned earlier with respect to fuel savings, duty cycles, reasons why maybe you're not saving the fuel or not seeing the returns. And then crew messages as well. So in some cases, if the crews need to take action, for example, go back to idle or go out of DB and go back into DB to reset the fault, this is provided with the display as well. So the integrated display I mentioned earlier. So here we're really talking about the driver's display. And if you look at traditional locomotives, you know, going back maybe some decades ago, and even on some today, the typical locomotive has a 26L type control stand, meaning analog gauges, mechanical gauges that are prone to failure. They're mandated by authorities for periodic inspection. And the integration of all these other subsystems, so you could have an electronic air brake system, another electronic system, so you have 6 or 7 HMIs in the cab, and it's not consolidated for the crews. So this is where our integrated locomotive driver's display comes in. So it replaces all the mechanical gauges that can be problematic and need maintenance. And in some cases, you can extend your periodic maintenance inspections. For example, the FRA in North America has 92-day inspection. And using this type of technology with others can extend those maintenance inspection periods to 184 days, which means less time locomotives are in the shop. And then some of the cab electronic systems and locomotive systems like head of train, end of train, electronic air brake, distributed power, cab signaling, to name a few, their messaging and information is all consolidated through this display as well, reducing the need to have separate displays for those components. And other things like integrated alerter functionality and the speedometer being in as well. And this displays are the graphical layout and the user interface is designed to conform to local guidelines for how driver's displays are meant to be laid out. Slide, please. Thanks. So this is a bit of a busy slide, but just wanted to basically talk through real quick how NEXSYS works. So the green items are components associated with NEXSYS. So the propulsion, so NEXSYS is taking all the commands from the crew and the train line in terms of throttle requests, powering, braking, and then it's driving the excitation to the traction alternator. In this case, this is a -2 type locomotive shown with a AR10 generator. So NEXSYS and this has feedback mechanisms from the traction circuit, voltage transducers, current transducers, all easily installed, and that can be easily diagnosed through NEXSYS. And they feed back that information into NEXSYS, which is trying to achieve the maximum horsepower for that throttle position, as an example, the maximizing adhesion, while keeping the rotating equipment like motors and alternators within their manufacturer's operating limits with respect to voltage and current. So that's the propulsion side. The integrated SmartStart functionality, I'm not sure if I mentioned this, maybe now is a good time. The SmartStart function that Lucas went through is integrated with every NEXSYS control system. So the engine stop-start function and monitoring of those parameters that we discussed earlier are also included here as well. Crash-hardened memory module. So NEXSYS monitors the key parameters that are meant to be recorded for the crash-hardened memory module in the event recorder. That is integrated and transmitted to the crash-hardened memory module. And then, of course, the remote connectivity, which we'll talk about, I think, maybe in a slide or two here. And then there's the integrated driver's display as well. So again, a bit of a busy slide, and I know I went through that quickly just because of time, and you're welcome to take a deeper dive into this once we have the slides available as well. So the data collection, and Lucas did a great job earlier of diving into this, and I'll recap. So users have a 24/7 access to near real-time data from all their NEXSYS equipped locomotives. So the data is in the ZTR portal, cloud portal, so our customers can log in and access and collect data for fleet health, fuel consumption, emissions, utilization, information on their propulsion systems, and starting performance, engine starting performance. They can export that data, trending, the location-based reporting, breadcrumbing, geofencing. There's also the alerting dashboard and more. And if you have some of our other systems like KickStart integrated, that KickStart information is available through this portal as well. So it's a great tool to report out to different parties, whether it be your investors, compliance officers, your mechanical team for maintenance purposes, or your operations team to demonstrate utilization. So the integrated SmartStart function, we'll talk a little bit about the returns now, the return on investment. So if you look at this graph, it's illustrating on the bottom axis percentage of in-service or availability for that locomotive. And on the right, on the left, the Y scale is the financial savings, again, in US dollars. So I think it makes sense that the more the locomotive is in service, the more the opportunities for fuel savings through the integrated AESS. And on the low end, locomotive with low utilization can still see $4,000 to $5,000 a year in savings. And on the high end, upwards of $30,000. So just to give an example of, depending on your utilization of your locomotive, what kind of savings you can expect to see from fuel. And this doesn't include any kind of credits behind the scenes that you may receive through carbon credits and that sort of things with emission reductions. Slide, please. So we did a bit of a case study on traction motors. I mentioned NEXSYS keeps the traction motors and rotating equipment within manufacturer's ratings. So we had one customer that had a very high traction motor failure rate, and it was due to over voltage conditions, commutator failures, thermal failures due to high current going through the motors. And when they installed NEXSYS with the traction motor protection, there was a 90% reduction in the traction motor failure rate. And one of their worst years prior to NEXSYS, they changed out 1,000 motors that year. So if you do the math, and if you look at a $20,000 per traction motor replacement, and the savings of a 90% reduction over 1,000, that resulted in $18 million in savings annually across their fleet with NEXSYS. And I should have clarified that previous study was on DC traction motors, not the AC brushless traction motors. And then just kind of summarizing some of the returns that you can expect to see. So we talked a bit about the AESS. So this is, again, a bit of an average. I mentioned the low and the high end. We have some additional features with SmartStart called Smart Low Idle. That provides some additional savings. And then, some customers have had in certain low speed operations where lifting is important and top end speed was not as important. If they had 3 locomotives, they were able to reduce to 2 because of the tractive effort gains. And if you think of the cost of operating locomotive maintenance, engine maintenance, and the costs, the fuel costs of running, they saw savings of about $15,000 annually, which equates to about $40,000 a year per locomotive, again in US dollars with this case study. That's a rundown through our control systems, a little bit about the performance, how they work, and some examples of some return on investments. And yeah, with that, I believe I will pass it to Lucas or Shabam? Or should I introduce Shabam?
Maybe
Yeah.
to me, I guess.
Okay, yeah. So I'd like to. Unfortunately, Garrett had to drop off. We had a little bit of a scramble we had to do here. So appreciate you working through that with us here. So I'd like to introduce Shabam, our senior marketing manager, who's kind of the brains and the facilitator of everything that goes on pulling these things together. So with that, Shabam, I will pass it over to you.
Thank you so much, Am. Hello, everyone. I'm Shabam, Senior Product Marketing Manager at ZTR. I'm taking over from Garrett, who had to leave for something urgent that came up. And yep, I believe this is a great presentation, and we hope you all found this insightful. And yep, this is about KickStart, SmartStart, and NEXSYS. To recap, I believe SmartStart can save more than 30,000 liters of fuel every year. It has a payback period of less than a year. KickStart has a 650% return on investment in 10 years period, and NEXSYS saves around 40,000 US dollars every year. So these are some great products we have built and bettered over the years. And yeah, taking on questions, we already have a few questions asked during the webinar, and please feel free to submit your questions. We take them as we see them. We have one for SmartStart. Lucas, would you mind taking this one? This was like, what if the locomotive is auto shut down and I have to perform maintenance?
Shabam, can you hear me?
Yep, I can hear you. Can you hear me?
Just messaged me and indicated he's having trouble unmuting.
Lucas. Hello. Can you hear me? Lucas, we are not able to hear you.
I think he's stuck on mute. So, Am, are you able to answer that question for Lucas on his behalf?
Yeah, I'll do my best, sure.
So yeah, I'll repeat the question, Am. It says, what if the locomotive is auto shut down and I have to perform maintenance?
Yeah, so you can, in those cases, you guys can hear me, right? I'm not muted. Okay.
We can.
Yeah, in those cases, for safety reasons, we also provide a switch that can be applied. And most EFCO or emergency fuel cutoff, we recommend that they be locked into a certain position and then tied back with a safety seal, so that and by doing this, that means SmartStart will not restart the locomotive at any point in time. It'll actually disable at that point. So the crews maintenance folks can safely perform their maintenance without fear of the locomotive automatically restarting while they're performing maintenance, if I understood the intent of the question. I'll also add that when SmartStart performs an auto shutdown and an auto start sequence, it doesn't just do it without any kind of notice. There's actually a sequence that involves, prior to each event, there's sirens that are provided with our systems. Not sirens, they chirp basically. There's one for the front of the locomotive, one by the engine compartment. They'll actually chirp. There's indicating lights that will flash to enunciate that SmartStart is about to either auto start the locomotive or auto shut down the locomotive. So there's warnings and enunciation that goes with it as well. So I hope that answered the question.
Yeah, I guess so. And Lucas, can you try speaking now?
Yeah, now that you've answered the question, I fixed it. Well, Shabam fixed it.
But anyways, we have a lot of questions for SmartStart, and the next one is, what kind of data does SmartStart provide remotely?
So the SmartStart will provide remotely basically all the same information that you can get from it locally in terms of the reports and the event logs. So in the reports, you get access to all of the accumulator information that gets you shutdown time, reasons preventing shutdown, reasons creating restarts, as well as you can run utilization reports and duty cycles. So understanding what percentage of time was in service, what percentage of time was loading, what percentage of time was idling in DB, things of that sort. And then there's also an event log that goes through kind of different starting events and things like that. They're logged by timestamp. So all of that information is available remotely. It comes in on a periodic interval multiple times a day. And through the platform, you can choose your reporting timeframes to get a isolated view of how it operated over a specified time frame.
Okay. And we have a question for KickStart. It says, is there a method for safely discharging the supercapacitors in the KickStart system prior to maintenance? So, would you mind taking that?
Yeah, sure. So and it's a great question because people are, safety is very important. So glad this question is coming up. There's two things. Each KickStart system comes with the ability to disconnect the capacitor system from the rest of the locomotive and completely isolate it. So if you need to perform some kind of battery maintenance or battery changeout, there's a disconnect switch. And when it goes into disconnect mode, as I mentioned with the EFCO button, there's holes that are meant for safety ties and for lockout if your railroad shop observes lockout practices. So the system can be safely disconnected. And also when you disconnect the system, it does go into an automatic self-discharge state at that time as well.
I think it's worth also noting that as per Am's diagram that he showed, there's actually two contactors inside the KickStart capacitor module. And during normal operation, those are only going to be closed either when you're assisting in a start or when the engine's already running. So if you're in a shutdown state and you're not starting the locomotive, those contactors will also be open. So even if the capacitor is charged, that doesn't mean that the leads are live and connected to the capacitor at all the times.
Great point. Thank you, Lucas.
Thank you, Lucas. Thank you, Am. And then we have this question which says, does it help to reduce electrical load on other locomotive systems? So I was a bit confused with does it help to, but if I match the time, I guess I'm quite sure this is for the KickStart thing. So would you mind taking that? Does it help to reduce electrical load on other locomotive systems?
Okay, I hope I understand the question correctly. So KickStart's primary purpose is to offload the batteries and support the batteries during the engine starting sequence. Supercapacitor is typically, batteries are still better as far as providing power for other loads. So in the application that we have with KickStart, its primary focus is offloading the batteries and not other loads on the locomotive.
Okay. Thank you, Am. And then we have another question for SmartStart. What happens if the AESS fails to start the engine?
So the SmartStart actually goes through a multi-start process based on OEM duty cycles. So if it fails to start the first time, it will go through a cool down cycle and then attempt to start again. And it will do that up to three or four times based on settings within SmartStart, maintaining that cool down cycle before it locks out as a failed restart. And at that time, it'll log an event that it's failed those restarts.
Thank you, Lucas. And then we have one question that I'm quite sure of the answer of, but yeah, I'll let Am or Lucas you to take it. So the question says, does KickStart need SmartStart to function or is it independent? I guess Am, you touched upon this, but yeah, why don't you take this one?
Okay, so does KickStart need SmartStart or is it independent? Is that the question?
Yeah. Does KickStart need SmartStart to function or is it independent?
Okay, no, KickStart is it can operate independently. It can operate on locomotives that have SmartStart, that don't have SmartStart, that have NEXSYS, that don't have NEXSYS. It's not mated to a ZTR product. But you can also look at it. Sorry, there's some feedback happening. Yeah, but you can look at it also in a, good, better, and best type thing. So KickStart on its own is great. You pair it with a SmartStart, you're enhancing the fuel savings as well. And then with NEXSYS, as I mentioned, you get the further benefits and you get the connectivity through NEXSYS as well. But no, we have KickStart installed on lots of non-ZTR locomotives, if I can call it that, on Progressville or EMD type locomotives, the Wabtec locomotives, different vintages across the decades. So no, you don't need to have the ZTR system or the ZTR system on board.
Yep, and I would like to add to what Am said, like, yep, we do not need a SmartStart for KickStart to work, but these both devices work great together, and your savings for each of these devices is amplified because KickStart provides the starting boost, and then the reliance on idling reduces for AESS device also. So the batteries are charged up, there's less reliance on batteries, and the supercapacitor does that thing. So we save more when both of these devices are together, but to answer it, they both work independently as well. And then we have, does the KickStart has lithium battery? So
Does it have a lithium battery?
Yeah, that's the question. Does the KickStart has lithium battery?
So the KickStart, its core component is a supercapacitor based system, but I mentioned lead acid batteries because that's where we've done a lot of studies. But KickStart is battery technology agnostic. It can work with lead acid batteries. It can work with, I think we've done some NiCad batteries on some applications and lithium batteries as well. Hope that answers the question.
Yes. In case it doesn't, please feel free to send a follow-up question. And then we have this one for NEXSYS. I assume this traction effort improvement was with a typical North American 30+ ton axle load unit. I believe this is the case study that we did with TTCI. This is on that. So it says, I assume this traction effort improvement was with a typical North American 30+ ton axle load unit. Was that do you remember?
So the SD, yeah, I have to do my math, but it was a pretty typical SD40-2 locomotive in North America, which I believe are about 368,000 pounds in weight. And their starting tractive effort is usually, help me out, Lucas, about 110,000 pounds starting tractive effort, something like that, or 90,000.
For -2?
Yeah, or was it
Less than
80,000?
Yeah,
Yeah, maybe 80, 85 or 90. And as far as the details of the locomotive, because I know in Australia and in New Zealand and maybe Tasmania, there's different types of locomotives that are still based on these types of this type of SD40 technology, so similar traction alternators, different types of motors, standard gauge, narrow gauge. But in SD40, the configuration was an AR10 traction alternator, D14 companion alternator, D77 traction motors, DC, 6-axle.
Okay, and then we have a quick follow-up question. It's not in sequence of questions we have, but I guess we can take it before the other ones. So it says, can you quickly explain again how the NEXSYS directly improves the tractive effort?
Sure, I'll take a stab at this, and Lucas, if you have anything to add, please feel free. So the -2 system, and a great control system when it was introduced, I believe back in the maybe 1970s. It was an analog system. It had some limitations in terms of the wheel slip control technology, the way it was done, the type of sensors, how the sensors were connected to the traction system, whether it was in series parallel or parallel. And maybe I'm getting too technical, but in terms of the traction configuration, it could look for certain types of slips with a certain traction configuration, maybe not in full parallel. So where NEXSYS and even some of our other products that focus on adhesion comes in, it's looking a lot more at the motor characteristics individually. Some of the traditional systems looked at pairs of motors as opposed to individual motors. So NEXSYS is looking at the voltage and the current characteristics of each motor. It is a microprocessor-based solution, so it's a much higher response rate. The way the adhesion control is done is at a much more incremental level than, say, the original system, which is a little more crude in terms of reduction of power when it sees a slip and harsh reapplication of power. And I should also note too that there's voltage and current transducers for every motor, and we don't utilize the use of speed sensors or speed probes that need to be installed with each axle, so that reduces the installation time and components as well. Lucas, I don't know if you have anything to add to that.
No, I think you captured it well.
Thank you, Am. And then we have this question that starts with, maybe I missed this. How does NEXSYS Smart Low Idle function work? How it contributes to the savings? So,
Sure.
Lucas.
You want to take that, Lucas, or I can take it?
Yep, I can take that. So traditionally, some of you may be familiar with like low idle panels, things where basically if you're in an idle function, it'll actually energize a and D valve to drop you to a lower RPM. Now, in the past, with it being a very rudimentary function, we've had a lot of reports from customers of issues that have come up with that. One of them being with that reduced idle, you can get higher excitation on your aux gen to try and maintain the battery voltage and battery charging. And what some of our customers actually ran into was they were finding that the aux gen field was getting burnt out because it was being excited too much too often. So part of what our smart low idle is we're looking at things like that aux gen excitation and the battery charging, as well as the main reservoir air pressure, to make sure that we're only going in low idle when it's not a deficiency to the locomotive operation or going to cause potential harm to equipment on the locomotive. So it's basically looking at that traditional low idle function, but adding more intelligence to it so that we're not basically implementing the same drawbacks that the original low idle had.
Yeah. Thank you, Lucas. And we just had like quick 5-6 questions different people have posted, but yeah, I'll take them one by one. So this one goes, remote monitoring would require network. Do you know what are the requirements of network for SmartStart and NEXSYS?
Typically, when we're providing that remote connectivity, it'll come with the SIM cards for the local network that it's going to be on. So we have different SIM cards for our remote telematics depending on the region that they're going into, and then that would come through into our back office system. That said, if there's data that people want to have in their own systems, there's definitely things we can do to set up APIs to forward that data or anything like that. So we're definitely open and flexible to the communication architecture and where data goes once we have that remote connectivity.
Thank you, Lucas. And then we have one for KickStart that says, can KickStart extend battery life even with older batteries?
The answer is yes. If you look at batteries, and I guess we have to quantify older, let's say 3 to 4 years are going just past that. I believe several battery technologies, the manufacturers expect 6, maybe 7 years maximum. So we're saying older, getting to maybe that 4 or 5 year period. Yes, as long as the battery can still hold some level of a charge, and then power the loads and power the starting circuit just enough to get to that starting sequence point. KickStart can, again, it will provide that peak torque and offload the batteries of doing that and extending the useful life of those types of batteries.
Yeah. And then we have a question which says, how much experience do you have with locomotive engines that utilize EFI? It follows up with electronic fuel injection.
Yeah, so we have integrated with electronic engine controllers type before. The idea with NEXSYS is that it's meant to be engine agnostic when it comes to, because really what it's doing is it's communicating to the engine. If it's an analog system, it'll communicate digital signals of the throttle request and take analog signals back for the engine load and RPM. If it's a comms-based system like a J1939 type-based engine controller, NEXSYS will communicate over that CAN bus or whatever the protocol may be, send the throttle commands, and then pull back the load information, the engine RPM information, and if there's diagnostic information that can be made available from the engine controller, we would transmit that information into our onboard display, and then also through the remote monitoring that Lucas and I have been talking about.
Yeah, and just in case their question was going towards SmartStart as well, there's no issue with SmartStart being equipped on EFI equipped locomotives. We've done several of those, having a specific option for units that are equipped with EFI for SmartStart.
Yeah, and thank you, Lucas. And then I have these two questions that I believe I can club. They go like, the first one is like, do you provide training to operate the AESS? The second question is, what is the learning curve for train operators and maintenance teams using NEXSYS? So would you mind taking one by one, or maybe make it club these questions because they're similar?
Sure.
Yeah.
Do you want to handle the SmartStart, Lucas?
Sure. So actually kind of generally for both, we have training material, including presentations and material that can be provided to the end customer. We also offer on-site, in-class and on locomotive training, especially for NEXSYS. We highly recommend that when a new customer is getting a NEXSYS system installed. And that goes through operation training, installation training, as well as understanding the interface with the NEXSYS, diagnostics, and then how to troubleshoot the locomotive. In terms of SmartStart, we also provide a decal that shows kind of the different operations, what the different parameters are and things like that. But we also have training material for that as well.
Yeah, if I can just add to what Lucas said, great points. The SmartStart, yes, there is some level of training involved because the crews have the ability to actuate an auto restart or, that kind of thing. So there's decals and training in that regard. When it comes to NEXSYS, with diagnostics, there's crew operation involved, accessing displays, that kind of thing. But largely the operation of NEXSYS when it comes to the propulsion, the adhesion, and some of the other things we spoke of, it's all transparent to the crew. They still come onto the locomotive and, start the engine, put the isolation switch and run, handle the throttle and braking commands as they normally would. And KickStart as well, I'll just add to that as well. The operation is transparent to the crew, so they don't need to press any buttons to get KickStart to help them start the locomotive. It's all transparent in the background.
I might just add on closing that off, so really well explained, is that now that Downer is the agent and the local presence for the ZTR, we've gone through a number of different trainings. We've had some on-site training with an installation of NEXSYS. The idea is our local support with additional training or anything that you need is that we'll be able to offer that locally.
Thank you, Ash. Thank you, Anne. And then we have another question which goes, how easy is it to isolate the SmartStart if we need the loco to be in idle? Lucas?
I'm not sure I fully understand the question, but if there is a disable switch on the SmartStart, so if you're needing to do any sort of maintenance or something where you want to prevent it from shutting down, you can disable the SmartStart so that it won't. Likewise, when it's already shut down, you can disable it to ensure that it won't restart if you're doing some sort of maintenance where you don't want it to.
Okay, so I would say the answer is it's pretty easy to isolate the SmartStart. We have a switch that we just need to turn on or turn off to make it work or not.
Yeah, basically.
Yeah, there's an isolator that's connected to the SmartStart system.
Yeah, I think sometimes the question, maybe I'm reading into it, but sometimes the questions are about the crews if they're at a red light and they know that they're going to need to start moving soon and they think SmartStart's going to shut the engine down. They can actuate a throttle command or a reverser command to extend the idle time a little bit so they don't disrupt the train operations. And the frequency with which these kind of things happen is also noted inside the report as well, the SmartStart report that Lucas referred to.
Thank you, Anne. Thank you, Ash. And then we have this question: is there a specific process for balancing power between the between the KickStart system and the locomotive's main batteries?
Sorry, can you repeat that?
Yep. I'll say that again. Is there a specific process for balancing power between the KickStart system and the locomotive's main batteries?
Right. So Lucas, again, you can, from the engineering side, feel free to chime in, but there isn't a balancing circuit or a balancing type solution between the batteries and the KickStart. The KickStart is basically isolated and charged. The battery continues its operation, and then KickStart is only brought online during the engine crank sequence, plus also online when it's charging, when the engine's running. And when that happens, because it has that ability to discharge much more rapidly than the battery, its energy will get to the starting circuit before the batteries will, and that's how it can provide that peak current. I'm not sure if I answered or understood the question, but Lucas, do you have anything to add to that?
Yeah, they're like it's connected in parallel with the batteries feeding the starting circuit, so there's not complicated electronics or anything like that shunt power more from one to the other. It kind of inherently does it itself. So because it's providing that initial very fast discharge, it allows the engine to get started rotating before it presents that really heavy load on the battery that causes that voltage sag, and that's why the voltage doesn't sag as much.
Okay, and then we have this question about, for an ST70 with an air starter rather than electric, naturally kickstart is probably not of benefit. Is there any other benefits to consider for this application?
Yeah, great point. A lot of them are fitted with the air start mechanism. Some railroads have still elected to install or keep their electric start system as a backup. So having kickstart as a backup to ensure that the electric start is going to be as close to 100% fail safe in the event that you have an air problem, or air starter motor problem, or a problem with that additional air reservoir, leaks or something like that, that's preventing the air start mechanism from coming in. So that would be a potential use case for kickstart on those types of locomotives.
We have a few more questions, but I would say this is the last one that we are taking, and then we move towards closing this webinar. So this one goes like, does the kickstart is in series or parallel to batteries? Does it affect the current or voltage? Depends on answer, or have adverse effect on starting RPM? So I'll repeat this question again. Does the kickstart is in series or parallel to batteries? Does it affect the current or voltage, or have adverse effect on starting RPM?
So it's in parallel, as Lucas just mentioned. When it comes online, it's in parallel with the battery, so it works in parallel with the batteries. And then the second part of the question was, does it have an effect on the voltage or current?
Does it affect the current or voltage, or have adverse effect on starting RPM?
So with the voltage and current, I'm assuming we're referring to the battery voltage and current. So the battery voltage won't dip as much as Lucas just outlined previously. The battery current contribution will be less because kickstart's covering and providing that overall or that peak current. So the current will drop off from the battery during the crank sequence at the beginning. Voltage will be a little bit higher. In both cases, it's actually good for the battery and good for the engine starting process. And then what was the last part of the question? I apologize for asking you to repeat.
No worries. And or does it have adverse effect on starting RPM?
No, if anything, because the voltage is going to be higher, it's going to provide higher rotational velocity because the voltage will be somewhat proportional to the engine rotational velocity or the motor velocity when the engine is starting. So it actually achieves a higher starting velocity, which means a better chance for success of starting the engine. And we didn't have it in our case studies, but one of the things we found with kickstart is an overall 25% reduction in average engine cranking time as well.
Right, and we do have a few questions, but I believe this is getting monotonous and people would want to have some time back. So I would like to invite Ashley for the next slide. Lucas, if you can help us with that.
Great questions, though.
Yeah.
So just on closing, first of all, really thank the panelists for sharing their time and giving insight. Really shows some really good benefits of your product range and also the return on investment. And we're fortunate enough to have Am and Raina, who I believe is on the call, to come to Ausrail and be a part of Ausrail with us this year at our stand. So please come and say hi. And I'm sure there'll be further questions that you have, and we'd love to be able to meet you in person and discuss these in more detail. So yeah, thank you very much. Thank you, the panelists, and thanks for everyone attending.
So yeah. Thank you everyone for joining, and we appreciate your engagement and insightful questions. And the webinar recording and the deck will follow within the next week. And look out for a post-webinar survey in your inbox soon. It should reach your inbox in the next 2 hours. And it will be great if you can provide your inputs. This will help us improve future webinars. And once again, thank you for joining us. Have a great day.